group data. And the second one is how to solve problem involving measures of dispersion. Okay, so before we start, I would like to share my screen first. Okay, I would like to share my screen. Wait for a moment. Okay. Okay, so I hope you can see my screen. Can you see my screen?
Yes, sir.
Okay, thank you very much. Okay, so we will start now without further ado. Okay, so I will just take two examples from your textbook, okay? And we will look at the solution together on how to compare two sets of group data, and also how to solve one of the problem involving measures of dispersion. Okay, so I will keep it full screen. Okay, so I hope you can see. You can see my writing. Can you see?
Yes, sir. Yes, sir.
Okay, thank you for your response. Okay, so we'll first we will look at one example. Okay, it's from your textbook, example 12. Is how to compare two sets of group data. Okay, so let's read the question first. A botanist sowed 40 samples of hibiscus seeds using two different hybrids, A and B. The diameters of both hybrids are measured under close guard to develop an extra large hibiscus. The following frequency table shows the diameters of petals for hybrid A and B. Okay, so the table already given. Okay, already given to you. And based on the mean and standard deviation, determine which hybrid produce larger and more consistent petals. Okay, justify your answer. So normally when we want to compare two sets of data, right, we will normally use mean and also standard deviation. Okay, standard deviation. So for the mean, if the mean is larger, means depends on the question. If for this case, right, the question is the cm is referred to the diameter of the petals. So if mean is higher, means that hybrid will have a bigger or larger petal compared to the smaller mean. Okay, so this means actually referring to the question lah. Okay, referring to the question. So if in this case the mean referring to the diameter of the petal. So if the mean is larger, means the petal will be bigger or larger also. If the mean is smaller, then the size of the petal will be smaller lah. Okay, and then the standard deviation referring to the consistency of the size of petals. Okay, the smaller the standard deviation, means the data for the group data is more consistent. Okay, the smaller, the more consistent. If the standard deviation is larger, then it's less consistent. Okay, so this is how we analyze, or how to explain or justify your answer using mean and standard deviation. Okay, so let's look at the first question, this question, example 12. So how to compare? So means for hybrid A, you need to find out the mean and standard deviation, and also the, okay, wait for a while. Okay, so for hybrid B also, we do the same thing. We will find out the mean and also standard deviation, okay, for each hybrid. So means you need to find out the mean and standard deviation for hybrid A and also for hybrid B. So we will do it one by one now. Okay, so given to you is this one, the class interval and also the frequency. So we should develop a frequency table first. Okay, so to refresh your memory, we need to find out the mean. Okay, the formula for mean. Okay, the formula for mean is actually, okay, the sigma fx over sigma f. Okay, and then for standard deviation, the formula is sigma fx squared over sigma f minus mean squared. Okay, and this is referred to mean. Mean is a x bar. And then don't forget the square root. Okay, so this is the formula. So in your frequency table, you should have your f, which is already given to you. This is your f. Okay, and then you need to find out the midpoint. Okay, midpoint is your x. Okay, you need to find out the midpoint. And after that, you need to find out the frequency multiplied by the midpoint, fx. And also you need to find the x squared, which is the midpoint square. And also you need to find out the fx squared, the product of fx squared. So all of this you need to find out in your frequency table. Okay, so we will look at the solution. Okay, no one coming in? Okay, so we continue. So for the first hybrid A, we will do the same thing, okay? Where this part, the diameter and also the frequency is, you just copy paste from the question, okay? Copy paste from the question, because it's the same thing, okay? You use back the same the same data given by the question. Oops. Okay. Please give me a few seconds. Okay, where am I? Okay. All right, almost there. Okay. Okay, so the first thing is, okay, you need to I cannot conteng pula. Okay, never mind. So the first thing is you need to actually make sure that the diameter cm this part and also the frequency this part, okay, you just copy from the original question. Okay, copy from the original question. What you do is you need to add some more columns here, okay, to find out what is your x, your fx, your x squared, and your fx squared. Okay, just like the previous exercise you did lah. Okay, because it's actually the same thing as the previous exercise. Just this part you need to compare. So actually you can get this one from your calculator, as I already taught you on the previous class. Okay, have you tried to use the calculator to get the answer? Anyone have tried the calculator? No one? Okay. If you can try, if you have a calculator, you can try to use the calculator to press and get the answer for the sigma f, sigma fx, sigma fx square, and standard deviation, and mean, so on and so forth. Okay, this will be very helpful when you check your answer. Okay, so after you find out this midpoint, okay, after you find out the fx, the x square, your fx square, just submit or substitute these values into the formula to get your mean and also get your standard deviation. Okay, so this is you get all these values from the table lah. Okay, get all these values from the table and put it into the formula and press the calculator. You can get the answer. Or you can before that you can also key in all this frequency and midpoint into the formula, into the calculator, and then just press the button and to get all this answer. Okay, it also can be accepted lah. But for in exam, I prefer you to, if the question asks, you have to draw this frequency table. But if the question didn't ask, it's also preferable to draw this table lah, okay, to show your work. Okay, if you want to just directly directly get the answer from the calculator, I think it's better for you to check the answer only. But for the work, to show how you get the answer, I think it's better for you to construct this table. Okay. So after you get this hybrid A, the mean and the standard deviation for hybrid A, so continue do the same thing for hybrid B lah. Okay, do the same thing for hybrid B. You just copy back this one, the same thing from the question, the diameter and also frequency. Okay, just copy paste. Make sure you don't copy wrongly lah, the value, especially the values. And then do the same thing. You get the x to get the fx, x square, fx square, and then substitute all this value into the formula, and you will get the mean and also the standard deviation for the hybrid B. And then lastly, you have to compare between hybrid A and hybrid B. So how to compare? Okay, so the back to the question. The question asks you which hybrid is produce larger petals and more consistent, right? So you have to answer this question. So to answer this question, for the petal first, which one produce larger petals? So your answer will be hybrid A, because the mean for hybrid A is larger than hybrid B. So you can write the value here, compare the value. For hybrid A is 14.35, as to hybrid B is only 14.1. So you say that hybrid A will produce larger petals because the mean is larger, okay, than hybrid B. And then for the consistency, you can look at the standard deviation. Okay, compare the standard deviation for consistency. So for hybrid A also, the standard deviation for hybrid A is smaller than hybrid B, which is 0.64, and hybrid B is 0.7. So hybrid A is smaller, which shows that the diameter of the petals is more consistent, okay, compared to hybrid B. So that is your justification, okay. So when you when you want to compare two sets of data, usually we use the mean and also the standard deviation. Okay, standard deviation normally we compare for the consistency, and then for the mean we only compare which one is larger, longer, or bigger, okay, long or shorter and something like that. Okay, just compare the mean. Okay, whereas for the consistency, use the standard deviation. The smaller the standard deviation, the more consistent the data. Okay, so that is the part for comparing two sets of data. And then the next part is I want to show you one example on how to solve a problem involving the measures of dispersion. Okay, so example 13. Okay, I'll read the question. A survey on the duration of time in hours spent by customer to buy goods in a supermarket is carried out. The results of the survey are shown in the ogive on the right. Construct a frequency table for the time taken by the customers to buy goods in the supermarket using the classes. Okay, this one. And then B, hence estimate the mean and standard deviation of the data. Okay, so this question you need to find out. Okay, you need to construct a frequency table. Okay, after that, okay, you need to find out the mean and also the standard deviation. So again, to find the mean and standard deviation, you need to have the x, which is your midpoint, your f, which is your frequency, your value of fx, and also fx squared, okay, and also the mean. So all these things you need to know in your frequency table. So if you want to know the midpoint, you first need to know the class interval first. So for this question, the question already given you the class interval, so it's making your life more easier lah. Okay, sometimes the question maybe will not give you the class interval. Maybe the question just give you an ogive like this, and then ask you to find the mean and standard deviation. So you need to find out your class interval from this ogive. Okay, actually from this one you can see you can get the class interval also, because if you remember, okay, if you want to find out the ogive, if you want to construct the ogive for the x-axis, we normally use what? We normally use this one is actually the upper boundary. Okay, the upper boundary from the class interval. So you need to know that, okay, this one 0.45 until 2.95 is actually your upper boundary. Okay, your upper boundary for each class interval. So we look at the solution. Okay, so from this ogive, if the question, let's say the question didn't give you this class interval, okay, you need to find it yourself. So how do I get this class interval? Okay, remember, if you want to find the ogive, this is the first, this is the class interval that before the first class. Remember, with the frequency 0. Okay, if you remember how to construct the ogive, you need to find out one class interval before the first class, okay, with the frequency 0. Okay, if you still remember. So if the question didn't give you this one, okay, you need to find out from the ogive. So how to find it? Okay, so I will write down, because you see this one is a 0.5 here, 0.05. Remember, if I ask you to find out the upper boundary, let's say for this one 0.9, the upper boundary for this class interval is actually, you just add the 5 behind this number. Okay, you will get the upper boundary, and then you add 5. Okay, you get the upper boundary. You add 5 behind, you get the upper boundary. So now you need to do the opposite thing. Okay, from this upper boundary, you need to minus 0.05. Let's say for 0.95, when you minus 0.05, what do you get? You will get 0.9. Okay, and this is your upper limit. Upper limit. Okay, this is your upper boundary, but when you minus 0.05, you get your upper limit, which is your this one, 0.9. Okay, because the first class is 0.5 to 0.9. So now I want to get this one. I want to get this one from this upper boundary. I want to get my upper limit. So what I do is I just minus 0.05 for each upper boundary. Okay, I minus 0.05 for each upper boundary. So my answer for this one, all of this one, the answer should be my upper limit. Okay, here, all of this is my answer. So if the question didn't give you the class interval, you can minus the 0.5 behind each of these upper boundaries to get your upper limit. Okay, so if this one for 0.45, if I minus 0.05, I will get 0.4. So this one is 0.4. And then the next one, if 1.45, I will get 1.4. And then 1.9, okay, followed by 2.4 and 2.9. So all of these are my upper boundaries. Upper limits. So how to get this one? Lower limit is you just add another 0.1 over here. Because it's 0.9, so the next number should be 1.0. This is 1.4, the next one should be 1.5. This is 1.9, next one should be 2.0, 2.4, 2.5. So by doing this, I get my class interval. Okay, from here I can get my class interval. This is very important, because if you don't get your class interval, you will not get your x, your fx and your fx squared. Because if you can't get this one, you cannot find your midpoint, right, which is your x. You cannot find it. So you need to make sure your class interval is correct. If you don't get this one correct, and all of this will be, you will get wrong. Your midpoint will wrong, your fx will wrong, your fx squared will wrong, and everything will wrong. So it's very important for you to get the class interval correctly. So if the question didn't give you, then you have to find it from your ogive. Okay. So this is how you find it lah. And then another second thing is how to find the F. How to find the F. Okay, it's very tricky here, because to construct an ogive, the y-axis is actually your cumulative frequency. Cumulative frequency, not your frequency. Is cumulative, meaning you need to add the previous frequency to get the second one. Okay, so now all of these are cumulative frequency, but when you want to construct your frequency table, you only need the frequency, not cumulative frequency. So from here, from this ogive, you need to determine your frequency, which is this one, okay, the number of customer, your frequency. How to get that? Okay, if you remember, you want to get this one, you need to add, right? You need to add the total from the previous to the new one. So from here, you need to do the opposite thing, which is you need to minus. Okay, you need to minus. So what you do is, the first frequency is always 0 lah. Okay, for this 0.4, the frequency, cumulative frequency is 0. So the first frequency should always be 0, which is the first class before the the class interval before the first class. So to get the second one, you will look at the 0.95. 0.95, if you look at the cumulative frequency, is 6. Okay, it's 6. So meaning the frequency is 6 minus 0. You need to minus the previous frequency or the previous cumulative frequency to get the current frequency. This is opposite to when you want to construct an ogive. Okay, this is totally opposite. If you know how to construct ogive, you need to add, but now you want to get the frequency, not the cumulative frequency, so you need to minus. So this one is 6 for 0.95. The cumulative frequency is 6. So to get the current class frequency, you need to minus 6 minus 0 to get 6. And then go on for 1.45. The cumulative frequency is 22. So what you do is you take 22 minus the previous one, the 6. So 22 minus 6, you get 16. So you do the same thing. 1.95, the cumulative frequency is 54. So you need to take 54 minus the previous cumulative frequency, which is 22. Okay, you need to minus this one. So you get 32. And then do the same thing, so on so forth, until you reach the final one. The final one is the 80. Okay, for 2.95, the cumulative frequency is 80. So 80 minus the previous cumulative frequency, 70. So the current frequency is 10. Okay, so for ogive is a little bit tricky, because you need to identify the class interval. Okay, if not given. And then the second thing is you need to find out the frequency. Okay, because in ogive, the frequency is not the frequency you want. Okay, the ogive, the frequency is cumulative frequency. So you need to make sure you find the frequency, not the cumulative frequency. Okay, so after you already found out the class interval and also the frequency, now you can proceed to construct your frequency table. Okay, just like the previous exercise. Okay, find the x, find the fx, x squared, and fx squared. Okay, and then find the total. Find the total of f, total of fx, and total of fx squared, and then submit or substitute all this value to find your mean. Okay, and then to find your standard deviation. And after you get this one, then that's your answer. Okay, this is how you solve this is only one kind of problem. One kind of problem involving measures of dispersion. Sometimes the question will give you not ogive, maybe histogram, or also maybe frequency polygon. Okay, if a histogram of frequency polygon is much easier because the frequency you can directly read from the histogram or polygon frequency. But in ogive, you need to find out the frequency. Okay, you need to do something. You need to minus. You cannot read direct from the graph. So this is the difference between ogive and also the histogram and frequency polygon. Okay, but once you get the class interval and frequency, and then the rest is just the same thing as you do in your previous exercise. Okay, find the x, fx, x squared, and fx squared, and then find out the mean and the standard deviation. Okay, so I think that's all I want to cover today. Okay, that is how to compare two sets of group data, and also how to solve problems involving measures of dispersion. Okay, the example I show you just now is ogive. Okay, and it's a bit tricky because you need to find out the class interval if the question didn't give you, and also find out the frequency, because ogive no frequency. It's only show you the cumulative frequency. Okay. Maybe after you try a few more questions, you know lah. Okay, you can try some exercises from textbook. Later, I will share the exercise, what you need to do as your homework today lah, in the Telegram. Okay. And Beverly just came in, and actually we already finished. So before I dismiss the class, is there any question you want to ask? Is there any question from the previous exercises? Maybe from the workbook, or maybe from the textbook or other? Is there any question you want to ask? Nope. Okay. YB said no question. But I didn't see you pass up any homework, YB, Young. And not many of you hand in your homework. Only a few regular students who hand in your homework. So is there any question you didn't hand in because you really cannot do, or you know how to do but you didn't submit your homework? I just want to know lah.